Myself, Mrs. Afroz Patan. I am Assistant Professor in Department of Pharmaceutical Chemistry and Analysis, School of Pharmaceutical Sciences, Vistas. My topic is Nomenclature of Stereo isomers. So in this we are going to discuss about three nomenclatures, that is relative configuration, absolute configuration and rotation of plane polarized light for different stereoisomers. So coming to the relative configuration. Configurations are assigned relative to a standard compound glyceraldehyde, which is originally chosen by a scientist called as Emil Fischer in year 1885 for the purpose of correlating the configuration of carbohydrates. Emil Fischer arbitrarily assigned the configuration 3A to the dextrorotatory glyceraldehyde, which is known as D plus glyceraldehyde. Here, the capital D represents dextrorotatory, and whereas plus represents it will deflect the plane polarized in a positive direction or right hand side. And whereas the levorotatory 3B is designated as L minus glyceraldehyde. In nature, many compounds and configurations besides sugars has been related to glyceraldehyde, which includes other biochemically important substances like alpha amino acids, steroids, and terpenes. Those compound configurations which relates to D-glyceraldehyde belong to D series, and those compound configurations which relates to L-glyceraldehyde belongs to L series. Through reactions also we can compare these relative configurations by chemical means, in which the configuration at the chiral center of interest is either retained or inverted stereospecifically. As an example, consider the reaction sequence which is shown below, where the configuration of plus lactic acid is related to plus alanine, because the plus lactic acid has been related to L-glyceraldehyde as the OH group on the left hand side, and it is related to plus lactic acid. Plus lactic acid, by a sequence of reaction with nucleophilic substitution, it will be first converted into 2-bromopropionic acid, and later on with nitrite substitution, and in sequence with reduction it will be converted into plus alanine. Here, the plus lactic acid and plus alanine is called as levorotatory. Why? Because the OH and NH2 is on the left hand side. Whereas all the simple carbohydrates can be given the configuration based upon this Emil Fischer rules, that is relative configuration. The configuration of the highest number chiral carbon in all simple sugars are considered for giving the nomenclature. Here if you see the C5 in glucose, that is also called as last but one carbon, or the carbon to the next to CH2 group. Here we have to consider the OH group. OH group in this C5 carbon is on the right hand side. So it is said that it is a dextrorotatory compound. Therefore, naturally occurring glucose which behave as dextrorotatory belongs to D series and also called as capital D plus glucose. Here capital D represents the OH is on the right hand side, and plus symbol represents that it deflects the plane polarized right on the right side. Before moving on to the absolute configuration, I am going to just revise about chirality. Chirality is a property of asymmetric carbon, or possessment of different groups or atoms attached to a center atom like carbon. The molecule or ion in chiral, if it is not superimposed on its mirror image, these molecules are also called as enantiomers. Generally, asterisk represents chiral carbon or asymmetric carbon, where the carbon is attached to 4 different group or atoms. Here, if you see the example, bromochlorofluoromethane is the best example which exhibits chirality. And as it is not superimposed on its mirror image, it behaves as enantiomers. Similarly, we have chosen an example of substituted amino acids. These also exist in 2 enantiomeric forms. So this absolute configuration was explained by a scientist called as Can, Ingold and Prelog. These are the 3 scientists who has designed some rules, and it depends upon the handedness. The right hand and the left hand nomenclature is used to name the enantiomers of chiral carbon, and the stereo centers are labeled as either S or R. So rule 1. First you have to assign the priorities to the 4 substituents which are attached to chiral carbon, with 1 being the highest priority and 4 being the lowest priority. Priorities are based upon the atomic number of atoms attached to the chiral carbon. Rule 2. Orientation of the least priority group, that is group 4. Keep in such a way if it is oriented into the plane or away from you. Rule 3. Trace the circle for the remaining 3 priority groups 1, 2, 3 in a order. If the circle comes in clockwise path, then assign the configuration as R. R means rectus. In Latin, it means right. Whereas when the path is in counterclockwise direction, then assign the configuration as S. S means sinister, and in Latin it is called as left. So you can see both the representations in the diagram. Clockwise direction it is called as R, and anti-clockwise direction it is called S respectively. So we are going to discuss this configuration with example glyceraldehyde. You can see glyceraldehyde which consists of 3 carbons, and the middle carbon will behave as a chiral carbon to which it 3 to which 4 different groups have been attached. Now you have to check the priority order. So we will go according to the rules. Step 1, you have to assign the priority. The atoms that are directly bonded to chiral center here are hydrogen, oxygen, and carbon in aldehyde group, and carbon in methyl hydroxyl group. Hydrogen will be the lowest priority group, so it will be assigned as 4, and the hydroxyl oxygen is highest priority, so it is assigned as 1. Whereas the carbon which is present in aldehyde and methyl hydroxyl group, we have to check the priority order. In aldehyde, we have a double bond attached to oxygen. So carbon, when it attached to oxygen, is compared with the carbon which is attached to oxygen in single bond with hydroxyl group. So if the same atom here like carbon is bonded to double bond and also single bond, definitely double bonds will have higher priority than single bond. Therefore, the aldehyde group is assigned as second priority, and later methyl hydroxyl group is assigned as third priority. And we have to check in step 2 whether the least priority group, that is hydrogen, is pointed away from us. Then later on trace the circle by the order 1, 2 and 3 according to the priority groups. So when we trace this, we have seen clearly that 1, 2 and 3 are in the order clockwise direction. So the structure which is given here will be in rectus form or configuration according to absolute configuration rules. Here we are going to discuss one more example. Absolute configuration representation is shown in a drug called as thalidomide. This is a very interesting example, and a tragic case study is associated with this, which represents the importance of stereochemistry during drug design. First, thalidomide is manufactured by a German drug company and prescribed widely in Europe and Australia in the year 1950. It acts as sedative drug and also remedy for morning sickness in pregnant women. Thalidomide was soon implicated as a cause of devastating birth defects in newborn babies to the women who had this medication with thalidomide. Thalidomide contains a chiral carbon center, and this drug can exist in two enantiomer forms. And the drug is present in racemic form, means both 50-50 percentage mixture of both enantiomers were present in the marketed form as shown in the figure. So we will see the left hand side of the above picture. So when you take this structure, we have to first assign the priorities, and generally the hydrogen which is being least prior, it is represented with priority 4, and the nitrogen atom which is having higher atomic number will be given first priority, whereas the carbon which is present in the Piperidine ring is attached again to both the carbons. So we have to check the priority order like in the ring. So second priority is given to the carbonyl group, whereas third priority is given onto the CH2 side of the ring. The reason behind this is, well, the carbonyl carbon is attached to oxygen, which is having more atomic number, whereas the third priority is given on the CH2 side, which is again attached to one more carbon. So thereby, after assigning all the priority groups, we have to check whether the hydrogen is pointing away from us. Then, when prioritization of all the groups got completed, we have to trace. So when we trace in 1, 2 and 3 direction, it is clearly seen that the direction is in clockwise direction. So the enantiomer here we are discussing is R enantiomer of thalidomide. Although scientists are unsure today how thalidomide works, experimental evidence showed that it was actually the R enantiomer that has desired medical effects for treating morning sickness, while the S enantiomer caused the birth defects in newborn babies. Even this knowledge about the drug, however, a pure all thalidomide is not at all safe. Why? Because the enzymes present in our body rapidly convert between the two enantiomers, causing the tragic condition once again. And the leftover nomenclature is optical rotation of polarized light. This we are discussing from starting onwards also. So whenever we prepare a compound as a solution, and through that solution, when a plane polarized light is passed, if there is a deflection in plane polarized towards right, then it is called as plus or dextrorotatory. And if there is a deflection of plane polarized light on the left hand direction, then it is represented by minus or levorotatory compound. Here, plus and minus erythros is having, according to relative configuration, L and D forms, and the structures are given for, whereas absolute configuration, plus erythros represents R form and minus erythros represents S form. So, by this, I will conclude this lecture, and these are the references which I have from which I have gathered the information. Thank you.